Hello, hello. Okay, so we're in the middle of chapter three. Chapter three consists of establishing some vocabulary, some basic understanding from three topics that we're going to need for the chapter four and chapter five material. The three chapters, the three parts of chapter three are languages, grammars, and graphs. And the truth is that folks often tell me that they have pretty good experience with things like languages, done a lot of operations with strings in elementary programming classes, for example. They often tell me that graphs are also familiar. They did breadth first search as a programming assignment kind of stuff, and they've done a minimum path in algorithms kind of. So they're very comfortable with graphs, and that leaves grammar. And of the three things, they tell me that grammars are the ones that are the least familiar, the ones that folks have told me in the past that the ones that they have the least experience with. So fair enough. So we'll start grammars maybe a little further back than we start the other two topics. So what's a grammar about? So the definition of a language says you start with some alphabet, capital sigma, and let's say the lowercase letters A through Z, and then you look at all strings of members of that alphabet. So all strings involving lowercase A through Z, say for example B, Z, K, and you call that capital sigma. And then a language, a script L, excuse me, you call that capital sigma star. And then a language, script L, is any subset of that collection of strings. There's no requirement for rule or rhyme or reason for language. It's just any subset at all. And the generality is perfectly useful sometimes, but in practice, typically language follows rules. That is, for example, the C language, you can't just hand a C compiler an arbitrary string of characters. It has to follow the rules of the grammar, the pattern that all programs in C have to follow. Okay, so we want to talk about those rules. And again, because it's been my experience that folks have a little less experience with grammars than with the other two topics in this chapter, we'll start a little further back with an introduction with a little justification. Okay, so here are some rules for English. English has lots of rules. It's not even perfectly clear that it's well defined, but this is a list of some rules for English. I wrote them in English, and then I wrote them sort of formally here in symbols. Okay, so the first rule is that a sentence can be made. It says can be made, doesn't say must be made. It says one possible way to make a sentence is you take a noun phrase and you follow it with a verb phrase. Okay, well, what's a noun phrase? A noun phrase can be made from an article followed by a noun. A noun phrase could also be made from an article, then an adjective, then a noun. And so what you're seeing is that we're having these rules for making languages. Might remind you of some of the rules that you saw in an elementary programming class. Here's how you make an if-then statement, kind of stuff. A verb phrase can be made with a verb followed by a noun phrase. And so we're getting these things that are expansions of other things. So a sentence, for example, is defined in part in terms of verb phrases. Verb phrases are defined in part in terms of noun phrases. Noun phrases are defined in part in terms of nouns. So when do you hit bottom here? And the answer is now. We're hitting bottom now. An article is the word the. The is an article. An adjective is young. One verb is caught. There are lots of verbs, and one of them is caught, and two nouns are man and boy. So what we're looking at down here is that this here is the basic part of the language. This is the alphabet for the language. This is not, you can't break THE into T or H or E when you're making sentences. That's not how it works. THE is atomic as far as English is concerned. That is to say, this is what we would call in everyday life a dictionary, but for the purposes that we're talking about, this is called the alphabet. So THE is a token. It's indecomposable. It's atomic. Another one is young, and etc. And then the language English consists of strings of words like this: THE, YOUNG, CAUGHD, excuse me, etc. So sentences are strings of members of the dictionary. Sentences are strings of members of the alphabet. But of course not arbitrary strings. In English, you're supposed to follow rules. And here I've written the rules in the formal language that we'll get used to in this section. So instead of saying a sentence can be made, we have sentence, arrow, noun phrase, verb phrase. You can read the arrow as expands to, or can be made, or can be constructed, or whatever you like. Noun phrase, you notice that there are two different rules associated with noun phrase, so you can have more than one way to construct a noun phrase. Verb phrase, article, adjective, verb, and down here, the last one. So up here I had noun, two different ways to construct noun phrase. On the bottom line, I really have two different ways to construct noun. Noun can be man, noun can be ball. I could have wrote it this way here with two different two of these different constructs, two different lines, but instead I chose to use a vertical bar here. So this is just simply a convenience, and also because it didn't fit on the slide if I wrote it as two lines. So this is noun can be made by using the word man. Noun can be made by using the word ball, and the vertical bar is just a convenience for putting together constructs like that because they occur a lot in grammars. All right, so time for some vocabulary. There was a bunch of rules on the previous slide. Every one of them is called a production or a rewrite rule. Each production or rewrite rule has a single arrow, and you notice, because I'm going to point this out later, that the arrow only has one line. That is to say, it is not a double line arrow. So that's a double line arrow. It is not a double line arrow. So let's get rid of the double line arrow. Okay, so to the left of each arrow is a head, and to the right is a body or an expansion. Is a head, so sentence is a head, noun phrase is a head, article is a head, and to the right is a body or an expansion. Sentence, arrow, noun phrase followed by verb phrase. The head is sentence, the body is noun phrase followed by verb phrase. Sometimes two rules have the same head, that can happen. There are also two rules for noun, but we've abbreviated by combining the two bodies together with the pipe symbol, the vertical bar that I just talked about a second ago. Now the rules use two different components. We have sentence, and it's written in italic types and put inside diamond brackets. But we also have some words that are just written in typewriter type, like man and ball and young. So the ones in typewriter type are from the alphabet that I talked about in the previous slide. You might think of the alphabet for English as being a dictionary. Those are called terminals because that's when it all stops. You stop expanding things when you get to the terminals. The sentence, you do something with sentence, you go on and turn it into a noun phrase followed by a verb phrase, but the word young, you don't do anything with it. That's it. Your young is going to appear in what you have at the end. So those are called terminals. The ones written in angle brackets and in italics, such as article or sentence, those are called non-terminals. Took us all day to think of that one. So those are like variables, and they're used for intermediate steps. And in particular, when you see a grammar, they're often used to describe what you're trying to talk about. It would be awkward to say X and Y and Z. If you have sentence and noun phrase, verb phrase, then the name of the thing is helpful. So these are sometimes called syntactic categories. The two symbols, a single line arrow and vertical bar, pipe symbol, are neither terminals nor non-terminals. They're what's called meta characters. They're part of the syntax of the rules. So they're not going to appear in the language. They're there to help us write down the grammar. So what do you do with the rules? And the answer is, of course, you make substitutions like you do in ordinary high school algebra. So those rewrite rules govern the derivation of strings in the language. Under the English grammar, every derivation starts with the word sentence. Okay, I wrote it first. Every derivation starts that way. Along the way, you get a mixture of non-terminals and terminals, and I'm going to go through an example here and say what's happening. So sentence. We saw that there is a rule that allows you to replace sentence with noun phrase followed by verb phrase, and I did. I replaced it. When you write down the rule, you use a single line arrow. When you do an actual replacement, you use a double line arrow. See the difference here? I've seen many people get confused by the difference between a rule and an application of the rule. The difference is subtle but important. Once you start with the double line arrows, you can never go back to a single line arrow. That's a mistake I see a lot of. So sentence can expand to noun phrase followed by verb phrase. Noun phrase can expand to article followed by adjective followed by noun. Verb phrase just got copied from the previous line. Article can expand to the, T-H-E. So what you're seeing is that you're doing some kind of algebraic replacement here of the various the non-terminals are acting like variables, and you're replacing them with things you're allowed to replace them with. The single line arrow describes the replacements that are legal. The double line arrow describes which replacement you actually did. So here, for example, there's two things you can do with a noun phrase. The rule says there's two things you can do with a noun phrase. I chose article, adjective, noun. So that's the difference between a double line arrow and a single line arrow. The single line arrow is the rules that tell you what are possible. The double line arrow describes what I actually did. And I got from the top to the bottom, of course, and I ended up with the sentence, the young man caught the ball. Okay. So the derivation above, the derivation that's here, always substitutes for the leftmost non-terminal. So noun phrase got expanded to article. Now article is the leftmost, article, adjective, noun. Now article is the leftmost non-terminal. I expanded it to the. Here, in this string, in this mixture of terminals and non-terminals, adjective is the leftmost. So I expanded adjective, and it turns out I'm allowed to replace adjective with the word young, and etc. And I happen to go down, always doing the leftmost one. And in principle, you could replace any of these on your steps from top to bottom, but you often see leftmost derivations. Okay, but in general, you could substitute for any non-terminal. So what we see here, sometimes folks tell me that this is actually a more familiar version of what's on the previous page, is what we see here is a different way of describing what we saw on the previous page. Sentence, of course, the very first step was to replace sentence with noun phrase followed by verb phrase, and there it is. At some point, I replaced noun phrase with article, adjective, noun, and like that. So what you see here is that this is an alternative representation of what we did on the previous slide. So the parse tree is an alternative representation of the linear derivation. Okay, so I'm ready for the definition of grammar. Now this is not the most general definition of grammar. I'm just sticking with the grammars that we will see in the remaining material in the book. But so it doesn't say a grammar is, it says a context-free grammar, because that happens to be a special case of grammars, the only one that we need. So most programming languages are context-free grammars. So anyway, good enough for our purposes. So a context-free grammar is gonna involve here some rules, some alphabet, and some non-terminals. So that's what it says here. It says a context-free grammar is a four-tuple consisting of these four things, where sigma is the alphabet. We talked about for English, the alphabet is words. It's a dictionary like the or car or ball. N here is a set of non-terminals, which I already mentioned are sometimes called syntactic categories. Non-terminals are the things that act like variables. They're the things in the example below, like start and left and right. We assume that they're disjoint and that neither of them contains the meta characters. Anyway, you would never think to yourself, I wonder what would happen if. So we won't worry about that too much. S is the start symbol. It was, in the English language, it was sentence. Our practice will be to always write the start symbol is the head, the left-hand side, of the rule that we write first, just because we need a rule, so that's the rule we're going to use. And then fourth, P is a set of productions or rewrite rules. So for example here, we can consider the alphabet to be lowercase a, lowercase b, the set of non-terminals to be start, written in italic typing with diamond brackets to make it easy to spot as a non-terminal, left and right similarly. And the start symbol's got to be one of the non-terminals, and I picked start for the obvious reason. And here are the production rules. It says 5 production rules. A person could be confused initially because there's 3 lines, but you'll remember that this is really 2 rules here. Left arrow, A followed by left, and left arrow, B followed by right is actually 2 different rules. And likewise here, this is actually 2 different rules. Do you remember that epsilon here is the empty string? Okay, the empty string. Okay, so we'll take the convention that the start symbol is the head of the first rule, in this case start, or in the previous example it was sentence. And here's a typical derivation using production rules. You'll notice the double line arrows in place of the single line arrows. Okay, so start, well, I'm allowed to replace start with A followed by left. In fact, it's the only thing I'm allowed to do, but anyway, I'm allowed to do it. When you look at A followed by left, you notice that I have a left in there, so I'm allowed to replace left by one of the legal substitutions. There are in fact two legal substitutions. I chose the first. So in particular, just in case a person is a little confused here, I'm taking that non-terminal, the diamond brackets and the left, and I'm replacing it with what's right there, the terminal A followed by the non-terminal diamond brackets left. All right, well, so okay. So I did that substitution. Now, left is, I'm allowed to take left and replace it with B followed by right. So, so I went nuts and I replaced it with B followed by right. I replaced what's here for left with B followed by right, the entire B followed by right. Okay, and then I erased the wrong thing. And then I took the right and replaced it with B followed by right. And then I took B followed by right here. I took the right. There we go. I took the right and replaced it with the empty string. And the empty string, of course, when you add it to a string, doesn't do anything. So when I have AABB empty string, that's the same thing as AABB. So what I've got here is that I've derived the string AABB following these rules. So AABB is one of the strings that you can derive from these rules. There are lots of other strings that you can derive from the rules. You won't be astonished to find that you could also derive AAABB from these rules. Okay, so we will be interested in those strings that can be derived from the rules. Here's an example. This is a part of the grammar of the C language, or at least some expression of part of the grammar of the C language. So what I have here is that a statement list is a statement or a statement list followed by a statement. And a selection statement, for example, is if open paren expression close paren statement, or if open paren expression close paren statement else statement, or switch open paren expression close paren statement. So for example, when you look at these three rules here, what it's saying is that if you have an if, you have to follow it with an open paren. The rules say that you have to follow the terminal if with the terminal open paren. And then you can put in an expression that you expand however you like, kind of stuff. So these are the rules. These are obviously a small number of the rules of the C language. Now here, the if in capital letters means any string that capitalizes to if. So really, we're taking the capital letters if as an abbreviation for lowercase if or capital I lowercase f or lower I capital F or capital IF. And really what you see is that this kind of stuff is, strictly speaking, what's in the rules, but it would be awfully tedious. Wouldn't it be awfully tedious if you had to write that every time you needed to write IF? So you see a lot of abbreviations in grammars because, and that's a theme that we'll see later, you see a lot of abbreviations in grammars just because it simply gets tedious for the writer and for the reader. I want to notice something about that grammar here, and just to go back to it here, I want to notice something about that grammar. Did you notice in the very first line that statement list is allowed to be defined by a statement list? That is to say, you're allowed to describe statement list, to define statement list in terms of itself. This is a recursive definition. You're allowed to define statement list in terms of itself. And a person could say, and a person very often does say, a person could say something like, wait, there's something funny about that. There's something very funny about that. Because suppose I had statement list, and I applied the perfectly good derivation to get statement list, followed by statement. And then I applied the perfectly good derivation to get statement list, followed by statement, followed by statement. And you see where I'm going? I'd never finish. I have some infinite construct. Okay, but the person who is thinking that has missed the point. The point of a grammar is not to start with non-terminals and see how crazy you can go. The point of a grammar is to ask, given a string, can you derive this string from the grammar, yes or no? Okay, I absolutely agree that you can do this. Feel free. But that's not the point. The point is I will give you a grammar and say, can you derive the following string from that grammar? And the answer is either yes or no. Okay. So don't let the recursive rules bother you in that way. So up here, for example, we see the same sort of thing here, that one of the rules for the grammar that I gave earlier in the earlier examples is that you're allowed to have left defined in terms of itself. It can be defined in terms of right, but you're allowed to have left defined in terms of itself. Okay, and again, just the point of the grammar is only that I ask, here's a string, can I derive the string? I don't say start with the non-terminals and see how quickly they can explode. That's not the point of a grammar. Okay, a comment for general practice, for if you Google around, what do you see? And also for later on in the book is that for the examples and exercises, when we're doing small scale examples and exercises, we often don't bother with syntactic categories. We often just use capital letters for the non-terminals and lowercase letters or digits for the terminals. And that again is just simply a convenience because there's a lot of writing involved, and instead of calling this, so instead of saying something like string, arrow, paren string, close paren, or string, it's supposed to be diamond bracket, isn't a very good diamond bracket there. Come on. There we go. Diamond bracket, string, plus, you get the idea, the whole thing is a waste. This is just simply more compact, easier to write, easier to read, and more convenient. That's just all there is to it. Okay, so a very common abbreviation is to use capital letters for the non-terminals and lowercase letters or digits for the terminals, and that's especially convenient in those cases where we don't really mean S to be anything sensible. It's just supposed to be an example. It's just supposed to be an exercise. If you're working with a complicated grammar, you don't want to do that, but if you're working with sort of a four-rule grammar that's meant as an illustration, then it's very useful. Okay, so we're down to the point now. So the language derived from a grammar is a set of strings of terminals. No non-terminals allowed in a language. No non-terminals allowed in the strings in a language. So the language derived from the grammar is a set of strings of terminals that have derivations that begin with a start symbol. So here's an example, and this is one of these abbreviation examples that I gave last time here with the capital letters and the lower letters. So the lower letters are meant to be terminals, capital letters are meant to be non-terminals. So let's let's see if we can derive. I have a string that I intend to derive. It is going to be A, B, B. So let's see how I do. So the start symbol is in the convention that we've adopted. The start symbol is always going to be the head, that is to say the thing before the arrow of the very first rule. Okay. So remember, derivation, double line arrow. Don't forget. And there's only one thing you're allowed, so I did it. Capital A, you're allowed to expand that to be lower a capital A. The B is still there. You're allowed to expand here, this capital A, you're allowed to expand it to be lower a, there we go, lower a capital A. The initial A and the closing B are still there. You're allowed to expand this capital A to be, you see what I'm doing here. The two lower A's that I started with are still there, and now I'm allowed to expand that capital A to be lower a, come on, lower a capital A, still the B. New line because I ran out of space. Whoops, I made a mistake. Whoops. Go back to the previous line. I apologize. Back to the previous line. I didn't mean to do this. I should erase it because it's a mistake. There we go. I'm allowed to take capital A and replace it with a lower a, and that's what I intended to do. And the capital B is still there. There we go. Now I'm back on track again. So that's supposed to say lower a, capital B. And now here we go. I'm looking at lower a, lower a, lower a, only written in better handwriting, lower b, capital B, and you see what's going to happen, don't you? I'm getting to lower a, lower a, lower a, lower b, and I'm allowed to replace capital B with a lower b, and there we go. The answer to that question is yes. And it doesn't take much imagination to see that the strings that you can derive consist of some number of A's followed by some number of B's, where the numbers don't have to be equal or anything like that. They don't have to be prime numbers or even or anything, but they both have to be positive. Okay, so if you give me a grammar, the point of the grammar is to define a language, to describe a language, to be the rules that tell me what I'm allowed to do to make the language. And the language is what I'm interested in. If you give me a string, yes or no, decide if it's in the language. And of course, this connects with what we talked about last time with deciding members of a language. Okay, closing comment about grammars. And this is not really something that we'll see very much in the following chapters, but it's one of these things that you feel obliged to say. You feel it's an important aspect of grammar, so I'm going to bring it up. So it's kind of a lagniappe. It's an extra topic. Here is a little bit of code that looks like it came from a language like C or Algol or Java, this kind of stuff. It says if something, then something, if something, then something else. Looks perfectly typical C. Okay, the question here, though, is this else right here. Because it's not 100% clear, is it? Is that else associated with this if, or is that else associated with this if? Just to format it in such a way that it makes it clear what I'm talking about, I took those symbols and wrote them here, and the indentation makes it look like the else is associated with the first if. Over here, the indentation makes it look like the else is associated with the second if. Of course, in C, you have to use curly braces to disambiguate, to make it clear who's associated with who. But in any event, just to try to make the point here, this is called a dangling else. An ambiguous grammar is one where some strings have two different leftmost derivations. That is to say, it's ambiguous which if the else is associated with. Okay, so I want to give an example, and again, this is really just sort of an extra topic, so we're going to just going to cover one example and then move on. So here's a grammar. Here's a grammar that pretty simple. Here is supposed to give you some simple arithmetic expressions involving plus and times and the digits 0 through 9. Just supposed to be a simple example. I'm going to worry about here the string 5 followed by a plus sign followed by 2 followed by an asterisk followed by a 3. And I have two different derivations, and really the first step is the only interesting one here. One of the things I'm allowed to do is replace expression with expression plus expression. That's one of the things I'm allowed to do. Check mark, I did that. One of the things I'm allowed to do, another thing I'm allowed to do is replace expression with expression star expression. Check mark, I did that example. Oh, I have an extra diamond bracket up there. Oh, sorry about that. Sorry about that. I'll have to fix that. Okay, in both cases, I took the leftmost thing. There's only one thing in the head, so there it goes, the expression. I took the leftmost thing and expanded it according to a legal rule. There we go, legal rule. Leftmost thing, expanded it according to a legal rule. But what I get in the first case is that the very first thing done is the plus, and the very first thing done is the times. And so I get two different parse trees. And of course, it's possible to imagine an example where the two different parse trees don't make any difference, but the two different parse trees do make a difference here. Here, if you had this parse tree, you would get a final answer for what number is represented by taking 2 times 3 to get 6 and adding the 5, which gives you 11. Over here, if you had this for a parse tree to decide what number is represented by the arithmetic expression, you'd take 5 plus 2, which is 7, and multiply by 3, which is 21, and 11 is not equal to 21, and so, oops, you're in trouble. So the fact that there are two different leftmost derivations here means that there's an ambiguity about which ambiguity about which number you're going to get for an answer. And I could give it to two different people, and two different people get two different answers, or I could give it to two different compilers, and one compiler does one thing and one compiler does another thing. Ooh, that's not good. Okay, so this is an ambiguous grammar. And again, we're not going to worry much about ambiguous grammars later on, but this is an ambiguous grammar. It simply means that you have to be careful when you write down the rules for a language that you're describing the language you think you're describing. It's a little on the tricky side. Okay, all right, very good.